already doing. Okay, so today we have to be do one project based on this interrupt concept. Okay, so based on this, while you're going to be learn about the timers, how to manipulate the registers and use ads. So in use art, how to transmit one data, and in this case, based on your learning this concept, you are going to be implemented that concept in different project. Okay, so how to do this, how to take this registers, how to read this data sheet and reference manual, and write a code for your own. Okay, so in this case today we have to be deploy the external interrupt with push button. Okay, so the purpose is going to be we have to use this external registers, okay, to be trigger on either falling or rising edge. This time what is actually going to be do is it is going to be blink an LED. Okay, so again, you need to be understand one thing. So today is the project which is based on polling method. Okay, there is a two techniques is there, guys. One is we call it as an interrupt. Another one we call it as an polling. Okay, the difference between these two is what is mean by interrupt and what is mean by polling. So interrupt means some actions, okay, some other functions can be happens in the processor. Okay, so already something which is happening when it is get halt. Okay, when it is get halt and go to this other work, it is called as an interrupt work. Okay, when the thing what is meant by polling is, so your processor will always check. Okay, will always check for to the interrupt is coming or not. It is not going to be do any other work. Okay, here if you just see this one, it is going to do some other task. Okay, here this is the task one. Okay, it is default. Previously, it is doing some task one. When interrupt is coming, it just halt the task one. Okay, and then move to this task 2. Okay, and then move to this task 2. This is how it is actually working. But if you are just checking in the polling, the processor which is only allocated for to be always check for when the interrupt going to be come. Okay, this is the two difference between the interrupt and polling. Today we have to be do based on this polling method. Okay, what it is actually going to be do your processor, okay, it is always going to be check whether that push button is pressed or not. Okay, so it is always going to be check that condition, it is pressed or not. So if it is pressed, it is going to be blink the LED. So this is how we are going to be deploy this thing. So this is the method called as an polling method. Okay, so if I want to be implemented this polling concept, what the project, how can I implement this? So first of all, you have to be open your data sheet and reference manual. Okay, so I'm just open the data sheet as well as my reference manual. Okay, both has been opened, and I just directly go to this page number 15 of block diagram. Okay, whatever it is, you just go to the block diagram. Okay, because it is very important thing. And here in this block diagram, you can able to see all the peripherals, concepts, and everything at all. So what we have been already mentioned it, guys. So today we have to be use this external interrupt, right? So today we are going to be use this external interrupt wake up. Okay, so we have to be configure this one. Okay, because it is going to be act as an interrupt. Okay, we have to be use the polling only, but it is act as an interrupt. Okay, and if I want to be configure that, what I'm going to be do first of all, I need to be enable the bus of ABB to bus, and then I need to be check it has connected with which GPIO pin. Okay, because first of all, you have to be checked. Sorry, guys. This okay. So first of all, you are going to be check which GPIO pin it has been connected because you have to be configure this external interrupt pin, right? So you have to be configure this external interrupt pin. So in this time, in this case, okay. So in this case, guys, you have to be specifically use this external interrupt pin. Okay, give me a minute, guys. Okay, so we are going to be specially use this interrupt pin. Okay, in the interrupt pin, which is present at the position of here. Okay, here this is the position, the interrupt pin is there, and this interrupt which is connected with the bus of ABB2 bus. Okay, and today I'm going to be specially taking the push button. Okay, today I'm going to be taking the STM32 push button. We can able to see this. Oh my God, sorry guys. Just happened. Give me a minute. Okay. So something which is happening, guys. So sorry for this interrupt. Okay, and so I'm just trying to be show with this help of mm, okay. I'm just go to this one, and you can able to see the uh push button. Okay, this is I'm just directly show in through hardware. Okay, so you can able to see this is the hardware which we are going to be use. Okay. Okay, so this is the hardware which you are going to be used, guys. So this push button, so this is called as a push button. This is called as a reset button. So we have to be find out which GPIO pin it has been connected. Okay, so because when I'm going to be press this, it is going to be LED is going to be blink. So this push button is going to be act as an interrupt pin. Okay, first of all, we need to be find it out which GPIO pin. Okay, that's what the mandatory thing. And this is the interrupt pin. Okay, and I need to be find out which GPIO pin it has been connected. Okay, so here you can able to see this, which GPIO pin it has been connected. Okay, sorry for this guy, so it is can't able to handle this. What's happened? Okay, guys, so some issues has been happened. Sorry for this one. I'm just open up the data sheet. Okay, so in this data sheet, you can able to see the page. So in this data sheet, guys, you can able to see that this interrupt pin. So this data sheet, guys, so you know that where it actually connected. Okay, so this external pin it has connected with which GPIO pin you need to be find it out. Okay, so you already know that it is connected with this ABP2 bus, and you are going to be finding out which is it has been connected. You don't need to be finding it out because you, with the help of the schematic itself, you can able to check this which GPIO pin it has been connected. Okay, okay. So in this schematic diagram, you can able to see that this is the user one. Okay, this is your blue color button. So this is it connected with this port C of 13th pin. Okay. So it is connected with this port C of 13th pin. It has been connected. So you got one conclusion like it is connected with this port C. Okay, it is connected with the port C. Okay, you already know that it has connected with this AHB1 bus. Okay, so it has connected with the AHB1 bus, and through with the help of this AHB1 bus, you are going to be start to write the code. So here in this case, guys, so first of all, in this, first of all, I've been written the AHB1 ENR bus. Okay. So because of I need to be get the GPIO port A and port A. Okay, because it is connected with this push button is connected with this one. At the same time, you are going to be get the knowledge of where your LED has been connected, because when you are going to be press the button, LED is going to be also going to be blink. So this is the green color LED. You are just having that. So this green color LED, which is just connected with the port A of 5. Okay, so you have to be find out the both the things. So both the port A and the port C has been connected with this AHB1 bus. So you have to be commonly write the address for this one. So how you are going to be declare? First of all, you have to write the data type like unsigned of 32-bit, and you have to be write the pointer that is AHB1ENR. So you can simply open up this debugging place and go to this SFRs, and here and so here you can able to check the things like yeah, here you can able to check the things of RCC register. So inside this RCC register you can able to see this AHB1 ENR bus. So you have to write the address for this one. Okay, first of all you have to be write the address for this one. So first you just complete this and then go to this ABB bus, because after you have been enabled this, and you have to be enabled the ABB2 also, because of this enable this because of to enable this extend pin backup. Okay, so what I'm will going to do is I need to be enable that one also, and for this case just open up the reference manual also. Okay, in this reference manual you can able to see this one. You can able to see the RCC register. Inside this RCC register you can able to see the ABP2 bus. Okay, so this ABP2 bus ABP2NR. So here you have to be enable the SysTick configuration. Okay, enable this bit you are going to be enabled here. For that you have to be write the address for this ABP2 bus and you have to be enable that. Okay, here also you can take the address. Okay, here also you can get the address for this one. So after that, guys, you have to be enable the register mode R for mode RA and mode RC, because this mode RA which is going to be performing for the output configuration. Because if you are having any microcontroller. Okay, so if you are having any microcontroller going to be take, so this microcontroller inside this, you can able to see that all the peripherals has been there, interrupt timers and everything. So each has been connected with the GPIO pin. For first of all, you have been find it out what the GPIO pin. Even for LED, even for push button, it has been connected with one GPIO pin. So we have been find it out what GPIO pin. It is GPIO port A5. It is GPIO port C 13th pin. Okay, both has been we find it out, but in this case, same thing you have to be find it for uh, your interrupt also. You already find it out. We have to be enabled. We have to set the what mode it is actually going to be do. So GPIO A of LED, it is going to be act as an output mode. Okay, so it is going to be act as an output mode, because when I'm going to be on, off going to be manipulated by the microcontroller. But GPIO C is a push button. When a user can press the button, it based on that it is going to be react. So first of all, when the user press the button, the microcontroller take the input. Okay, it is taken as an input and provide that to the output, like your LED. Okay, if the user press the button, the input is telling, okay, someone has pressed the button, so you're going to be blink the LED. So if not pressed, it is going to be not blink the LED. So based on that, it is going to be happens. Okay. So the thing is, next of all, yeah, we enable the mode RA and the mode RC. Okay. So here you can able to see the mode RA, mode RC. So you can able to see the GPIO of mode R. Okay. So it is a general purpose thing. And in this general purpose register, you can able to see the mode R register. And in this mode R register, I can't able to scroll the page, guys. So it's having some issue. Give me a minute. So in this motor register, you can able to see this. So they have been given which mode you are going to be set. Okay, here they have been given. So which mode you are going to be set. Okay, so input, output, or alternative or analog. So I need to be set the output mode at the mode R5, because GPIO 5 it is going to be act as an output LED, and GPIO 13 it is going to be act as an input. Okay, so that's what I need to be set 00, and I need to be set 01. Okay, so this is what I need to be do it for the input and output configuration. So before that, I just written the address for both the stuff. What is the address of this GPIO and what is the address of this GPIO, and then what I did is I just uh, configured the thing, because here previously I just set the bit, because AHB1ENR is the pass, AHB1ENR is the pass. Here I need to be enable the GPIO A. Okay, so where the GPIO A has been presented in this AHB1ENR, so it is presented at the zeroth zeroth position. So I need to be set the 1. I need to set 1 at the position of 0. Okay, where the GPIOC has been located, it is located at the third position. So I need to set 1 at the position of 2. Okay, that means how many times you are going to be shift. Here it's not telling the position. Here GPIO is located at the third position. How many times you are going to be shift? Like 1, 2 times you are going to be shift. Okay, so that's what it is actually telling. And the same time you have to be enabled for the system enable this ABP2. So you already know this, right? So inside this ABP2, it is having this external interrupt. You have to be enabled that one also. Okay. And after that, you have to be set the mode. Okay. We already set the mode R A, it is act as an output. Mode R C, it is act as an input. So for mode R A, it is going to be act as an output. Okay. In this time, what I did is, first of all, I just disable the stuff. So 3 means it is going to 3 means it is a 1 1. So 1 1 I'm just shifted up to the 10 times. You can able to see this one. Now it's working. So the thing is, you can able to see this guys. Yeah. So 1 1 you're going to be for initially I'm going to be set 1 1 on here. Okay. Initially I'm going to be set 1 1 on here. Okay. So and then I'm going to be reset it. Okay, because the mode GPIO 5 GPIO 5, that means port A already set it. So that's what it is considered as a port A motor. Okay. And now you're going to be simply set, and again you're going to be reset it. Reset means you're going to be give the not operation. So not means it is completely zero. How many times you're going to be shifted to be set this position as zero? They are going to be shifted up to 10 times. 10 times, right? You can simply put 10, or else you can put 5 multiplies of 2 or 2 multiplies of 5. Anything is good. You can use 10 also. That is also fine. First of all, you just reset this position, and then you're going to be set to the bit. So what bit you're going to be set? You're being set the 0 1, because the LED is going to be act as an output. Okay. So for that, you have to be set the output, that is 1 0 1. Okay, on this position. Okay, now if I want to be set 0 1, this is the binary value. It is going to be called as in 2. Okay, what is the binary value? It is called as in 2. So 2, I need to be left shift up to 5 into 2. That means or 10. 2 left shift up to 10 times. If you want to be set the bit, you have to be use OR operator. If you want to be reset the bit, you have to be use AND and NOT operator. Right. So the same thing I've been did here. Okay. Sorry guys, it's not yeah, sorry. So 0 1 is it's not, I'm not going to be shift to 0 1. It is called as in 1, not 2. Okay, only 1 0 is going to be called as in 2. 0 1 is 1. Okay, I need to be put 1 on here. That means 0 cross 1. We need to be shift up to 10 times. Okay, you have to be make sure you have to be use that scenario. Okay, and I've been enabled this one. And system configuration means, because of that is the interrupt, guys. That is your interrupt. Okay, you can able to see this one, this ABB2, which is connected with this external interrupt. Okay, so you have to be check it on the reference manual also. You are going to be checking the reference manual. Okay, you have to be enable this. You are going to be using this system configuration. If you are going to be do this, you have to be first of all enable that one. Okay, so you are just to go to this ABB2 ENR, ABB2 ENR. Here you can able to see the system configuration. Okay, so you have to be enable the system configuration to be on. Okay, because this is extra interrupt wake up, so it is going to be called as your system configuration pin. Okay, that you have to be enabled here. Okay, and after that you can use that extra interrupt, as well as you can use this system configuration pin also. Okay, because inside the system configuration pin, you are having an external interrupt. Through that external interrupt only, you can able to manipulate the complete stuff. Okay, so first of all, I'm just I've enabled this one, and then go to this. So up to this portion we have been completed, and then we have to be set the mode. Okay, so for same thing, yeah, for GPIO-C also you're going to be set, but GPIO-C, it is consider it as an yeah, your GPIO-C is going to be considered as an input mode. Okay, We can able to see this one on here. In this GPIO's moda register, this input. So because the push button is input, right? So it just telling 0, 0 because before initializing everything, it is in this reset condition of 0, 0 only. So how can I make it specifically? It is going to be 0, 0. No need to be do this, but we have to be, first of all, we have to be set that position as 1, 1. Okay, before that, we are going to be set the position as 13th moda register. You have to be set 1, 1, and then you just simply reset it. So it is understand they have to be trying to be configured as an input mode. Okay. So first of all, I just set the 0, 3. That means 1, 1 means 0, 3 at the position of 26. So that's what I just splitted the value in this 26 position. You have to be set at 1, 1. And after that, you just simply reset with the help of the not and operator. Okay. Up to this, we just simply set it output and input mode. Okay. So now after we are going to be go to this technical concept, you just simply go to this. First of all, you just go to the system configuration. Previously, we have been enabled. So in the system configuration, you're going to be check which external interrupt you're going to be used, because here in this diagram, it is having external interrupt only you have been mentioned. Okay, in this diagram, it is mentioned only the external interrupt. Okay, so in this external interrupt, it is connected with your GPIO C 13th pin. Through that only you're going to be manipulate. So how you can able to enable this external interrupt is with the help of this system configuration. So here you can able to see the system configuration. You have to be enable that, and through that only you can able to configure the system configuration. Okay, first of all, you just go to this one. You just go to this system configuration, and you just go to this external interrupt. So in this external interrupt, you have to be tell which GPIO pin you have been used. So I've been used the 13th pin. Okay, I've been used with the 13th pin. So you're going to be set to the 13. Which pin you have been used here? You have been used the port C. Port C you have been used. Okay, so in this port C, you're going to be replacing here, and here it's just telling port C of 13th pin. And what the pin you're going to be set? You have to be set 0, 0, 1, 0. Now you're going to be set. So your external interrupt of port C, through that system configuration, it is going to be enabled. So you're going to be through the system configuration, you're trying to be actually it is going to be enable, it is going to be interrupt with the help of the GPIO open. So what the GPIO open? Port C of 13th pin. So that you have been telling. Okay, port 3 of 13. That pin is going to be act as an interrupt pin, right? Extra interrupt pin. So if you want to be enable this extra interrupt pin, which is present in the system configuration. Okay, so that's what we have been enabled on here. So that's also we have to be implemented here. So we have been implemented. First of all, external interrupt of CR4. So you are going to be go to the system configuration. Here the system configuration. Here the external interrupt of CR4. So you can ask one question: why did you or didn't use this CR3 or CR2? Because these are the sixth pin, fifth pin, fourth pin, seventh pin. I don't want this these pins. I want only the 13th pin. That's what I just choose in this external interrupt of CR4. Okay. And in this external interrupt of CR4, I need to be use the address. So what is the address? Yeah, I need to be write the address for this one. External interrupt of CR4 address, which is 14. Okay. And then you just simply enable the 13th pin. Okay, you just simply enable the 13th pin. If I want to be enable the 13th pin, it is contain the 4 pin. So because of this 4 bits, I just consider it as an F. F means it is 15. Okay, which is 4 bits. Okay, and first initially I'm going to be enable the 4 bits on this position, and at the same time I'm just reset this one. So 0, 0, 0, 0. Okay, I just simply disable this one, and I'm going to be left shift up to 4 times. Okay, it has been successfully reset the position, and again I'm going to be set the position. So what I'm going to be set? need to be set 0010. So what is the value? It is value of 2. Okay, 2, I'm going to be left shift off up to 4 times. This time, I'm just simply enable the 13th interrupt pin. Okay, it has also been enabled here. And this is the very, very important statement because of you are just toggling it as an interrupt. So if you want to be configure it as an interrupt, you already set in external interrupt of 13th pin you're going to be use. Okay. And now you just come to this external interrupt. So you can able to see this external interrupt events. In this case, you have to going to be read out the complete stuff, the main features of external interrupt, independent trigger and a mask on each interrupt or event or line. Okay. And generation up to you can able to do the 23 interrupts you can able to do and status bits of for each interrupt line. So what is the status which is having? And it is connected with this ABB2 clock and everything they have been given. So if you are taking one interrupt, what are the registers which is actually presented here? So it is actually required the pending register, interrupt mask register, and a software interrupt enabled register, rising and falling trigger register. So based on that, it is having the complete thing. And you're going to be read the functional description. To generate the interrupt line should be configured and enabled. This is done by a programming the two trigger register with a desired edge reduction and by enabling the interrupt request by writing one corresponding bit in the interrupt mask register. So first of all, what you're going to be enabled. So if you are not if you are confusing you just simply see this whether you're going to be using the hardware interrupt or software interrupt or hardware event selection. So we know that we are going to be specifically use this hardware interrupt, that push button interrupt. Okay. So now you have to be enable the this configuration of which bit you are going to be actually going to be used. Before that, you have to be enable the IMR. Okay, so interrupt mask register you have to be enabled, and then you have to be enable the trigger selection of both rising edge and falling edge. Okay, and if you are completely configure it as an interrupt, you have to be enable the NVIC also. Here I'm not going to be using this NVIC because it is completely polling method. Okay, you just cross verify that. If you want to be generate the interrupt, this is done by two trigger register of falling edge and rising edge. And also you have to be interrupt with the writing one at the interrupt mask register. Okay, same thing which is in the present in the point. They have been given in the content. Okay, so if when the selected edge acquires, so extra interrupt line is going to be give the request. Okay, at the time the pending register to the interrupt is also going to be set. Okay, you are going to be set this one also by writing one on there. Okay, so NVIC means nested vector interrupt service routine. So it is actually happens in this interrupt concept. So whenever you just having the multiple interrupt which is coming, so based on the priority, it is going to do the interrupt. Okay, so that is the NVIC. But in this scenario, guys, it is just telling this is for the event interrupt. Okay, this is for the event interrupt. So we are going to be implemented this these steps on there. Okay, first of all, you have to be enabled the interrupt mask register. Okay, interrupt mask register, which is called as an IMR. So in IMR, you have to be find it out where is IMR. So this is the interrupt mask register. When you're going to be set one, it is not going to be masked. Okay, you're going to be set one on there at the position of 13th one. Okay, here you're going to be set as 1. So for to be not masked. Okay, and after that's what I've been done here. First of all, I've been initially write the address. So here you have to be write the address for this IMR. Okay, so based on that, what are the address you have been required? You have to be write it, take it from here. And here, if you just scroll down, so I've been set at the bit of 13th bit. Okay, for to be masking this one. So I just simply use the set the bit 1 and then second procedure what they have been given configure the trigger selection bit both RTSR and FTSR, both rising edge and falling edge. What it is actually telling us when you're going to be press the button when falling when at the falling edge, it is going to be trigger this LED, or when at the rising edge, it is going to be trigger that. So I'm just enabling the both the things. So both the time it is going to be blink the LED. Okay. For that, I just put enable both the stuff. Okay. If you just see this one, okay, it is EMR. Whenever you're just going to do the event enable masking register, you just go to this rising edge. I need to be enable the 13th position because 13th pin I'm using. I'm just enabling this, and falling edge I'm just enabling the 13th pin also. Okay. At the same time, you have to be enable the pending register. So what it is actually telling, this pending register should be cleared because when the pending register going to be used is whenever you are going to be do this interrupt concept, multiple interrupt, your pending register which can holding the uh, pending data is going to be stored. So when it is completed, it is going to be moved this data. But there is no pending registers going to be required. You are going to be clear this to be set one on there. Okay, so for that, I just simply put one. Okay, and just simply enable that 13th position. So all has been enabled by the 13th position. And finally, I'm just what I'm going to be do is continuously when I'm going to be press the button, when I press the button, it is act as a like we have been polling method we are going to be implemented. So it is going to be always going to be checked. That's what I've been written on the while one condition. Okay, you can able to see this. I've been written the while one condition. While one means continuously it is going to be checked for whether it has been happened or not, whether it has been happened or not. Okay, so if I'm written this external function or condition, it is considered as an interrupt. So in this while one, you have to do some other routine task. So it is considered as an interrupt. Okay. But here I just given the interrupt function in this while one. So then it is considered as a polling function. Okay. In this polling function, I've been written one value. Okay. Declare one value. And through this value, I'm going to be read the data. Okay. So this value is equals to initially I've been declare IDR. So what is mean by IDR means input data register. Inside this GPIO, if you want to be take the output data register, you just use this one. If you want this input data register, you have been using this because, for example, you are having microcontroller, you have to be blink the LED, it is going to be called as an output. Okay, you have to be give the data. You are having a, if you want to be take an input, you want to be read the data kind of thing, you want to be read the data through this one sensor or anything else, it is called as an input data register. So this input data going to be stored on this register. Okay, so in this scenario you already set it, you can clearly see this concept. Okay, so I'm just having a two data register. I'm having microcontroller ODR register, microcontroller input data register. So if it is a, this is a microcontroller and this is your LED. Okay, so and this is a microcontroller and this is your push button. Okay, or push button or any other sensor, you just take it as an example. Okay, this is your push button. So in this time, if you want to be enabled this bit, you just give the data. Like I'm just give one to be blink the data. If you just simply give one, it is going to blink. If I'm just give zero logic, it is going to be off. Okay, that is what it is going to be considered. For this, if you want to be do this procedure, you have to be use the ODR, output data register. So with the help of this output data register, you just simply give one or zero to enable or disable. But here it's towards like this direction because whenever the user press the button, okay, whenever user press the button, the trigger going to be go to this microcontroller. That's what we have been connected the 13th pin. Okay, so when the user press the button through this 13th pin, the trigger is going to be trigger will go to the microcontroller. Okay, so when it is go to the microcontroller, automatically the IDR get updated. Okay, this time you just understand this ODR can have operated by the user by 1 or 0 by manually. When I'm going to be write 1 or 0 manually, it is going to be 1 or. But this ODR updated by the external peripheral. When the user press the button, it is going to be updated by 1. Okay, so when the user not pressed, it is still 0 kind of thing. It is going to be happened here. Okay, you also you can write 0 or 1. So anything you can able to consider it. For this condition, what we have been did is in this ODR, okay, in this ODR, 13th pin I'm going to be manipulated. Okay, so just think it here when the user, okay, so for if the user going to be press the button, it is going to be considered as in zero. Here I've been written this logic. Okay, when the user press the button, it's automatically triggered the 13th pin. Okay, so it is automatically trigger the 13th pin. Okay, so okay, so this is the push button you are having. This is the push button you are having. So you have been directly connected the 13th pin. Okay, so it is in this pull-up logic. If it is in this pull-up logic, it is directly connected in this 13th pin. This time, it is logic defaultly 1. Okay, 13th pin is 1. You just consider this 13th pin is 1. How do you read the data? You just have the data of 0, 0, 0. So you have to read total data. So to avoid this garbage value, I just simply move this at the 0th position. Okay, I'm only going to be read the data. Okay, this 13th pin, I'm just made the right shift up to 13th time. Okay, so for this time, okay, for this condition, I need to be 13th position. I'm going to be do. I'm just simply masking with 13. I'm just uh, right shift up to. I mean, I'm going to be okay. So I need to be set to the bit. I'm not going to be set any bit, so I'm going to be simply IDR going to be, you know that it is defaultly presented at 13th position. Okay, so from the 13th position, I'm just simply right shift the bit and make it the that IDR pin at the last and simply mask with this one. So I will get one. So when it is one, it is not action, any action has been going on. So when the user press the button, when the user has been pressed the button, so it is automatically go to this I to low logic, I to 0, 1 to 0. Okay, so when it is go to the 0, it is going to blink the LED. Okay, you can able to see this. So when it is pressed it, if value becomes 0, you are going to be blink the LED. But here, instead of set the bit, I've been used toggle bit. That is XOR operation. What does mean by XOR operation? So XOR operation means it is continuously going to be happen the things again and again. Okay. Initially, the ODR register not has been set it. Okay, ODR register has been in this reset condition, and you have been trying to set the fifth bit. Okay, so be okay. So you have been trying to be set the fifth bit. Now you are going to be do the XOR operator. So same thing going to be same, and different bit is 1. Okay, now this ODR has been updated. Now ODR has been updated as 1000. This is on condition. Now it is on. So 0. Okay. Now we are trying to be use the same logic. So now the ODR has been updated as 1000, and you are trying to be set the bit, shifting the bit of 5 times. So shift the bit and do the OR operator, XOR operator. Now the same bits are 0. Same bits are 0. Now it has been off. Okay. Now you have to be updated this ODR. Okay, now this update this ODR 00 on this ODR 000 again this condition. So now you can simply see this on off condition going to be continuously going to be happens again and again. Okay, so whenever the button has been pressed, it is going to be happens again and again. So here I'm going to be show the output. So here I'm just simply added one delay, guys. Okay, so here I'm just simply added one delay. For to be you should visibly see the LED blinking. Okay, I'm just simply right click it and go to this debugger and debug configuration. And in this debugger, you can able to see this scan and directly go to this debug. Okay, so you just simply see this when after I just debug this. So this is how it is actually going to be looks like. I'm going to be run this code. Okay, and after I just run this code, I'm just simply press the button. The LED is going to be blink. So when I press the button, the LED is going to blink. So when I'm going to be press the button, the LED is going to be off. So how it has actually happened? Because this is logic. So first of all, 0, 0. This is going to be enabled. So when I'm going to be press the button at the 0th logic, so it is going to be LED is going to be on. Okay. Sorry, I'm just reset button has been pressed, guys. Sorry. So in this condition, next condition, when I'm going to press the button, so the LED is as blinked, and I'm going to be again press the button, it is going to be turned off. Okay. So 0 means it is going to be uh so when I'm going to be press the button, when it is get 0, it is going to be off. Okay, so when this is just the logic when you, if it is the value 0, it is, but not exactly, it is not, we are not making 0. You are trying to be using this bit setting only. Okay, and then only when I'm going to be setting 1 or 0, it is going to be understand whether LED going to be blink or not. Okay, don't look out this 0. Okay, this logic inside this simply value 0. Just the logic we are written here. Inside that, you have to be setting and resetting again. Set again off, on again off. So it is going to be happens. Okay, continuously.